later on, just so everyone knows that. And if there's people joining, I will let them in as well. So guys, welcome to the 4th session of the AI crash course together with us at AI Sweden and Women in AI Sweden. This is not our last, but after this one, we have one more session left. And today we will get a bit nerdier, or we will dive into the area of machine learning and deep learning. And our expert today will actually be a proper and real expert in Sheetal Reddy, my colleague from AI Sweden. But as per usual, we already finished a networking session. Some of you got to talk to each other, and we'll create new rooms for a check-in that will get to share some news or some interesting thoughts. But first of all, I want to welcome up Jonna to talk about women in AI. For there might still be some people that think about women in AI or have questions around women in AI. So Jonna, please introduce women in AI.
Thank you. So yes, as most of you know that has been in these sessions, the previous ones, me and Sophie is part of the Women in AI Sweden core team and are facilitating this course together with Peter and Raquel from AI Sweden. And for those who doesn't know about the Women in AI community, it is a global nonprofit funded in France that works towards gender inclusive AI that benefits global society. And today we have over 6,000 members in about 115 countries all over the globe. And we welcome all genders and personalities to contribute to our mission, which is to increase diverse representation and participation in the field of AI. Women in AI is a community-driven initiative bringing empowerment, knowledge, and active collaboration through educational initiatives, research, and events. And as said, Women in AI Sweden has partnered up with AI Sweden to host this educational initiative, that is the crash course. And just a little heads up, we have another event planned in June called AI Solving Sustainability Challenges, SDG 2030. And we will post more information about that on LinkedIn before the weekend. So please have a look out for that one. And my name is Jonna. And when I'm not a part of or working with Women in AI, I'm working at a small consultancy firm called Substorm that focus on intelligent automation, which is the combination between traditional automation and AI and machine learning technologies. So yes, that's about it.
Great, Jonna, thank you. And the event you're hosting on the Sustainability Development Goals in June is really an excellent way of bringing up the topic that we discussed last time, solving real world challenges. And that's why we need AI. That's why we are so happy that you are so interested in this technology. I've heard or I've listened in on a quote from Andrew Ng earlier today, actually, from an old interview that he had when he was talking about technology being useless in isolation. So this is really an area we need to talk about. We need to talk to different verticals and different areas of expertise to get everyone to understand on how to use AI. And that is also what we at AI Sweden do on a daily basis. We are a national initiative to help accelerate AI or applied AI all across Sweden, both in public and in private sector. And to do that the best, we have to find out what challenges or what problem we want to solve. And that is also why we want to give you an introduction to machine learning and deep learning today with Sheetal. So going back to the agenda today, we will do a short check-in now so that you get the chance to interact with each other and get to know each other. a bit more, and there will be new breakout rooms compared to the mingle or the networking session previous to start. Then after that, Sheetal will give you an introduction to machine learning and deep learning. We'll do some talking. You will have the chance to ask questions and discuss things in the room. Then when at 7 o'clock, when Women in AI take over, we will have a expert joining us as well from in terms of Anna Hjalmarsson, the head of AI at Electrolux. And you will also have the chance to bring up questions that you've been thinking about or ask her questions later on. But going directly into the check-in, today's topic is really energy. We started talking about the gray weather, but today we will want to focus the checking on energy. What brings you energy right now? And also, if you have the time in your rooms, or if you choose to answer that one, what's one new and interesting thing you've been thinking about lately? So for example, for me, it's I will study philosophy during this summer. So I've been going and digging my way into old philosophers through podcasts. So I'm in a bit of an existential crisis right now. So if you guys, if there's anyone else that are thinking about the existence of life, please just ping me and we can bridge to that existential crisis together. But I will send you out into breakout rooms now to talk about these questions, and I will give you 5 minutes to do so. So see you here back in 5. And Sheetal, you don't have to join a breakout room. Sheetal, I have actually 2 of you now, which is interesting.
Is it? I got logged out after you started the breakout rooms.
Okay, I'll remove the wrong Sheetal and I will keep the one you have right now. Don't report, remove. There we go. And Jacinta is joining as well. And I will send her to a breakout room. Let's see. Jacinta, we are in breakout rooms for 3 more minutes. I'll try to assign you to one. And
thank you.
Let's see when people join. People are starting to get back. Priya, welcome back. Anna, welcome back. Millie, welcome back to the room. This is where I really want to try to get people to use the chat, because after a couple of months in isolation, I really think we all need tips and recommendations from on what makes you or brings joy or energy as of now. So I just wanted to hear from a room, for example, Ingrid, you were in room number 1. What did you share in room number 1?
So time went quickly. We talked about that one in our group was pregnant, so that was learning new things every day. I talked about just started boxing, and that gave me energy. And my new role at AI Sweden, that I'm learning a lot. And there was another lady in my group that was also learning the technical side. She was working a bit with AI, but on the business side of it. So she was trying to learn more of the technical terms and stuff like that, the same thing that I'm interested in. So it was great talking to them. It was a very diverse group.
Cool. I think that's so cool in this group, that there's a lot of diversity. There's a lot of different aspects or interests. So please use this time to share. If you have something to tell from your room, please use the chat function. Write what you've discussed in terms of energy or interest as of now. And also, when we start today's presentation, please also use the chat function to add or just put all of your questions in the chat function, because we will try to pick them up, and also this is all of your questions is helping us informing the format and the future topics we are having in this setting or in this course. So please use the chat function as much as you can, because this is the second last, or this is our 4th session on machine learning, and then we will of course continue the dialogue and continue the learning community we are building together here in the Slack channel. So if you aren't using that yet, please jump on in and connect with us through Slack. But today's topic is machine learning and deep learning, and therefore I brought one of the people that I know that are very pedagogic and can really explain all of the themes and all of the areas, including in these areas. So please, Sheetal, the stage is yours.
Oh, thank you, Peter. That was a nice introduction. So I'll quickly share my screen. Yes, done. Right. Okay, so a little bit of about myself before I move to the presentation. My name is Sheetal Reddy. I work as a data scientist at AI Sweden, and my interests are in the intersection of computer vision, robotics, and at AI Sweden, I'm part of the decentralized AI team, and I'm working on problems related to federated learning, which is really interesting. You can just Google the term, and it's one of the solutions for the privacy and GDPR problems that we are facing in Europe. So, intro to machine learning. So the goal and scope of this presentation is to really acquaint you all with the terms, the technical terms and the terminology used in machine learning and neural networks. So starting with this picture, which I really like, a picture of Margaret Hamilton, who has coined the term software engineering, and the stack of paper was supposed to be the code she and her team has written for the Apollo program. It's really fascinating to me, and I think serves as a motivation for this presentation, that we can achieve everything and anything. And I was also fascinated to create a data scientist picture. What does a data scientist look like? And then I came up with this. It's less stack of paper because we do not write so much code because there's TensorFlow, PyTorch, and package for everything. and which is an advantage in itself for everyone to get started as quickly as possible. So I'm expecting after this presentation, you'll go back, learn that Python, and take that Python course you have been waiting to take. So yeah. So you have been learning about artificial intelligence, listening about it for the past 3 sessions, I guess, and just want to set up a little context. So what is machine learning? Um, let's talk about first what is artificial intelligence and how do we kind of define it. So artificial intelligence is basically a study where you try to find patterns, and it is how you enable machines to think like humans. And machine learning is one way to achieve artificial intelligence, unlike the rule based systems. And how we do that by learning insights from data. And deep learning is a subset of machine learning where we use certain kind of algorithms called deep neural networks. So just want to be clear before I move to some advanced concepts. So machine learning is broadly classified into 3 paradigms of learning. And one is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is like classroom learning, where a teacher teaches you what is right and what is wrong, and you learn from what the teacher has taught you. And then there is an exam in the end where you check how you're performing. But unsupervised learning is a little bit different. It's the learning that you do outside a classroom. Outside a classroom, we generally try to find patterns in life, connect the dots. It's the same with this as well, where the AI tries to find the clusters or patterns in the data. And then there is another interesting paradigm called reinforcement learning. So reinforcement learning has a different style. It is applied to tasks which are not, which are super complex and not so much comprehensible to us, like the skill of walking. When we consider the skill of walking, what matters more is if you have moved forward or not, instead of actually understanding what is the angular velocity you have used while you're walking. So basically goal oriented. So reinforcement learning algorithms is also goal oriented, and you achieve that certain goal by giving the AI or the agent some rewards and some punishments. In this presentation, we are going to talk a lot about supervised learning. In supervised learning, data always exists in pairs. So if you have an image saying an image of an apple, then you have a label saying that it is an apple. So data always exists in pairs. It's a sample. The image is a sample, and the label which says that the image belongs to an apple is a label. And you give these pairs to a algorithm, and the algorithm learns from this data, and then eventually you test how well it is performing. So what is it essentially understanding? Basically it is creating these distinguishable representations, learning from the data that is given to it, and then it is understanding, or it is generating some distinguishable representations. Let's say if you're given apples and oranges, so what is those representation that distinguishes between an apple and an orange? That is something it is learning in these classification tasks. So we are going to do something, some kind of a classification task ourselves in the lab today, using a data set called MNIST dataset, which is a handwritten digits 0 to 9. And you're going to classify them, you're going to build a model which can classify it into 10 digits. So some basic terminology that generally people use in machine learning and deep learning. We use something called as a training data set and testing data set. So once you get a data set that you have to build a model on, you split the data set into training data set and testing data set, and you show only the training data set to the model that you're going to build, and then you keep the testing data set to validate how well your model is performing. And there is something called inference time. Inference time is important because your model cannot take really 5 minutes to infer on that particular sample. So it is also important that your model is fast and also and accurate at the same time. And again, we have talked that in supervised learning, data is always in pairs. If there is an apple image, there is a label saying that it is an apple. So this label is also called as ground truth in scientific terms. So you give these pairs to the model, and the model trains on these pairs, and then uh, you get, in the end, you get a model which predicts accurately on the testing dataset. So I keep talking about this model, but what is a model? So let's look at it in the coming slides. So looking at this equation, y equal to wx plus b, where y is the label of an input example, x is the input example, w is the weight, and b is the bias. So as I said, data always exists in pairs. So that means we have X, we have Y. What we do not have is W and B, which are weights and biases. And almost the whole of machine learning and deep learning is to figure out how do we find these weights and biases. But when I look at this equation, it kind of rings a bell from our math class in school. What is y equal to wx plus b? So it represents an equation of a line, which is y equal to mx plus c, where m is the slope of the line and c is the y-intercept. And there are many versions. It's just not y equal to wx plus b, but it can be a polynomial where it comes in many versions. Y equal to w1x plus w2x, but everything is a line. It's linear. But why is so much of importance given to these lines in machine learning? So let's say we are going to classify cats and dogs, uh, and we got a new point, a data sample, which we have to classify whether it is a cat or a dog. And how do we do it? We'll draw a line and we say that all the points that fall on the right side of the line are belong to cats, and all the lines that fall on the left side of the line are dogs. And there can be many lines that you can possibly have. But in the second case, where you can where there are let's say there are mice and squirrels, because they kind of look very similar, uh, in such a kind of data set you cannot really draw a line. So what you do is you have a curve. So the data set in the second case is a non linearly separable data set, and the data set in the first case is linearly separable. That means you can actually draw a line, and that line will tell you the new test samples where they belong to. So these lines and these curves are your models. So the equation that I have showed previously, y equal to ws plus b, and this equation is your model. So how do we actually get these models? What do we mean by building these models or training these models? So we follow different algorithms. So the difference between an algorithm and a model is you apply certain rules called algorithms on your data, and the output is a model that will give you a proper accuracy. So in the same way, supervised learning algorithms can be classified into classification algorithms and regression algorithms. Classification algorithms are what I was talking before, like where you have to classify them into certain uh, categorical variables like classes, like dogs, cats, in that way. But regression is where the output of your model is basically a real number, let's say float 0.23. So generally you use regression to predict something, so predicting the future house prices uh, depending on historical data. These are the use cases that where you use regression algorithms. So how do you do regression? So the goal of regression is to predict a real number. And what happens in regression is that when you have your data and you have your target variables, target variable that is a ground truth that we have. So regression, essentially what it does is that it gives us a relationship between the dependent variable and the independent variable. So in y equal to wx plus b, x is a independent variable and y is a dependent variable because it depends on x. So the regression gives you a relationship between your independent variable and your dependent variable. That means you can, let's say you have your data points like this, and what you can essentially do is probably fit a line. And once you fit a line, when you have your test samples, for example, the house prices, you have historical data and you want to predict what happens in the future. So you through that relationship that you have got, where you have fitted a line through the data that you have, you get a y value for it. And how do you actually fit a line? You do something, you calculate something called as a least squares error. So how do you get a least squares error? So you have all these points, you take the y offset of these points to the line. So this line has to have the least y offset value. And such a line is the best fit for the data that you have. So we keep talking about this y equal to wx plus b so much. And let's say we have an image. Uh, what is x here? Do you give the whole image to the in x all the time? That is one question. So for example, if you have dogs and cats classification, so what is x1 and x2 here? X1 and x2 can be an image, or it can also be some distinguishable features that you think will be better in getting this line that can classify them in a better way. So for example, if I take cats and dogs, and I wanted to build a classification model on cats and dogs. So my X1 and X2, as a data scientist, probably I would decide X1 and X2 as, let's say, ears size and tail size. So I say that these are the most distinguishable features between a cat and a dog. So those will be my X1 and X2. Fair enough. But who has to decide this? So that is the difference between machine learning and deep learning. So in machine learning, a data scientist will sit and hand pick all these features which he or she thinks are distinguishable, and then he or she will give that to a classifier, which and the classifier learns to classify between the cats and the dogs. And that is something that is different in deep learning, where you give the images as is, and the deep learning or the model, the neural networks model, will figure out which are the best distinguishable features for that particular task. So that is the whole difference between machine learning and deep learning. Deep learning is also fascinating for the same reason, because it is learning those distinguishable features which are perfect for that particular task. So let's look at some traditional machine learning classification algorithms. The most simplest of everything is K-nearest neighbor. So how K-nearest neighbor works? How do you classify using K-nearest neighbor? Let's say this black big dot that you see here is a test sample, and you have to classify where it belongs to. Is it this green? Is it red? Is it red samples? Is it, or the other, some other colors? And how do you do that? So according to K-nearest neighbors, what it says is, uh, let's say when K equal to 1, you calculate the Euclidean distance between this sample and all these samples, and whichever sample is very close, you say that that sample's label is assigned to the test sample. So this sample is very close to green. So if K equal to 1, the test sample is classified as green. And if K equal to 5, that means you consider 5 training samples like that, and calculate the distance and get the closest 5, and then and then see what it belongs to. Here actually it, let's say it's close, 3 of red are close to it and 2 of green, 2 of yellow are close to it, then this belongs to red. Yeah, it, or if I say 3 of yellow are close to it and 2 of red are close to it, then it belongs to yellow. So that is how you classify a data point to different classes. Now, the problem with K-nearest neighbors is it is easily affected by noise, like outliers. And we were talking about model and algorithm. So K-nearest neighbor is an algorithm, but what is a model here? Because I don't see any kind of y equal to wx plus b equations here, right? So the model, the what you need, the whole data set to always classify your test sample, because there is no model here. The model is the whole training data set itself. So now let's discuss the another fascinating concept of neural network algorithms. So neural networks are inspired from the biological neurons in our brain, and in neural networks, the basic unit is a neuron. And if you, the figure that you're seeing here is called as a multi-layer perceptron model, where the neurons are interconnected, and there are like different layers. There is an input layer, and then there is an output layer, and then you have like multiple hidden layers in your neural network. And this is a multi-layer perceptron, which is a very old technology, which is not used so much now. uh, but why don't we use it is something I'm going to explain in the coming slides. And the equation, you will see it again and again, the y equal to wx plus b. So here also you see that y equal to wx plus b. So these this neuron or this perceptron, in the perceptron, the output that you get is always a weighted sum of inputs, and then you send the weighted sum through an activation function. Why do you do that? So we were talking about before, remember, the non-linearly separable data sets. If you don't, this activation function actually brings in the non-linearity to your model. If you don't use the activation function, the equation is just going to be y equal to wx plus b, or and versions of it, and it is always going to be linear. That means lines and not curves. So that so if a data set is non-linearly separable and you are just using a linear model, then probably you would not get a better accuracy at all. So if your data set is non-linearly separable, that means you use a more complicated model, and activation function helps you in giving that non-linearity to your model. So let's see. So what are we essentially doing in a neural network over here? We are sending some input, let's say it's an image, and then we are getting an output. Uh, it's a label, say it's a cat or a dog. And what is happening inside, what we are essentially doing is we are mapping the input to an output. That means for every input, you're mapping to an output. And what you essentially have to do is figure out this function where you're given an input and gives the expected output. So and how do you figure out this function is by training the model. So how do you train neural network models here? Uh, so like a human brain, because let's say a newly born kid who uh, uh, who has just been born, and in his or her brain, it's completely random. So in the same way, when you have a neural network and when you have connections like this happening between the layers of neurons, in the same way like your brain, and everything is initially random. So you uh, initialize it with random numbers and random weights. And what you do is when you send an image, you send it through this neural network, and you would get an output. And this output will be also random because the weights are initially random. And you get some random output, but you know what you want to get. If it is a cat, okay, I know I have to get a cat uh, here. That means, let's say you're sending something, you got a value 1, and you're supposed to get a value, uh, you're supposed to get a value of 1, and you got a value of 0.5. So there is some error. You are expecting something, you're getting something, and there is some error between them. You have to minimize this error. So you define a cost function or an error function here between what you got and what you're expecting. And when you get that error, you back propagate that error so that you get a new set of weights now. And this happens in an iterative process till in the end you get what you expected. So that is how you train a model. And for this, you use something called as a backpropagation algorithm. Uh, I'm not going into really the mathematical details, but backpropagation algorithm happens, at least the current ones, we train with batches. Like how I explained, I send a single image. It doesn't happen with single images. You batch a set of images and you send it through the neural network, and you get a set of outputs for which you figure out the error using the cost function, and you back propagate that error back into the neural network, and these weights are adjusted. So everything happens in batches and not with single images. So how do we so now we understood that something is happening in the weights, and we are getting a set of weights which are the perfect weights, and for those weights, whenever we're sending a cat, we are getting a output saying it's a cat, and whenever we're sending a dog image, we are getting an output saying it's a dog image. But how do we reach those set of weights? Because initially we are going from random, and then we are sending each and every data, each and every batch. But how do we tune it in a way that you reach a point where the cost is actually minimum? So how we do that? So it's a bit more complicated here. It's okay if you don't understand this, but just keep in mind that this is an algorithm called gradient descent that we use. So in gradient descent, what we do is we so this is our cost function, that is an error function that we use, and it is a function of our weights. And we have some random weights, and we have to reach this place, the global minimum, where the cost is minimum, that means the error is minimum. So at this global, to reach this global minimum in a structured fashion, you have to follow an algorithm called gradient descent. So the gradient descent says that if you follow the negative of a gradient direction, you would eventually reach not a global minimum, but a local minimum. So just keep that in mind, where if you have a weight at a certain point of time, in the next iteration, your weight will be something as w minus learning rate into cost function, gradient of the cost function. And this alpha is called learning rate, which you will be tuning also as part of your uh, lab uh, lab next. And then we will talk about it if you have any questions there as well. Okay, I'm going to move a little bit faster now. So now let's say there's a handwritten digit, which is like 28 cross 28 pixels, which is 784 pixels. Now we are saying that we are going to give this to a multi-perceptron network. And we say that, okay, we are giving pixel 1 to the first neuron, pixel 2. So basically, we are distorting the image completely and then giving it to the neural network. But that doesn't sound right, because there is context in these images. If you completely distort the image into a single vector, then the context is gone. And that's why the multi-layer perceptrons have become the old technology, and now what we are using now is called convolutional neural networks. So convolutional neural networks preserve the spatial context in your images. So if your image is uh, this, you don't have to really make it a one-dimensional vector. And you have something called as a convolutional filter, which goes through like a sliding window fashion, and then convolves on top of the image, and then you get a convolved feature. And these features are your weights that and are part of your model that we talk about. So models consist of weights and biases. So these features are our weights. So a traditional convolutional neural network has many different kinds of layers, like convolutional layers. We talked about activation functions like ReLU, and then there are pooling layers, softmax. So it's a combination of different layers which do different mathematical operations. This slide just shows that the weights that we have, as in once we convolve, and how do you get the weights. And then there is something called as biases, but I'm going to skip this here. Another important concept is that when you train a model, you have input layers, and then you have your output layers. So it is your model can essentially be segregated into something called as a feature extraction part and a classification part. So what happens is when you train a model like this with images or NLP or anything, the final layers of your model are very much specific to the task it is trained on. That means when I have trained my model on classifying cats and dogs, my final layer is very much specific. Final layers are very much specific to that particular task. But my initial layers are not. They contain low level features. That means, for example, if it's an image, then these contain features like edges, colors, blobs, that way. That means these are not very much specific to the task that you trained on, which makes it easier to reuse that features. That's where transfer learning comes in. So you might have heard that I fine tuned a model. What does it mean by fine tuning a model? That means someone has already trained from scratch a model on a very big data set, and then what you're doing is you're not changing anything in the initial layers because they can be reused, and then you are just changing the final layers because they are very much task specific. So that is what is transfer learning, where you train it where you train your model on one data set, but you can reuse the knowledge for another kind of task. Traditionally, in computer vision, a lot of models are trained on a very huge data set called Imagenet. It has almost 1 million images. And what most people do is fine tune these models on their data sets, which are very small compared to Imagenet. So this is something I've talked about also, where what you do is you copy the initial layers to uh, to just that way, however they are, and just the final layers are trained, that is fine tuned, because the final layers are very specific to the data set you have trained the model on, but the initial layers are not. So this is a very important concept, because mostly when you use images or text, what you would be doing is fine tuning your model, which is already trained on a very large data set. But uh, we cannot train models from scratch, because if we do not have that kind of an equipment or GPUs with us. So fine tuning makes it a lot easier to do this than actually training models from scratch. Another neural network which I just want to introduce is something called as Gans. Till now we were talking about something called discriminative networks, but here this is something which generates new data, and those are called GANs. So in GANs, it's super interesting architecture where it has a generator and a discriminator, and the generator takes in a noise vector, and it tries to generate samples, which artificial samples which look realistic. And what the discriminator does here, the discriminator tries to take the samples from the generator and also the real world samples, and it tries to discriminate and see if they are real or fake. And imagine putting both of them in a gamified fashion, and see if generator can fool the discriminator. And at that point of time where the generator can fully fool discriminator and discriminator cannot figure out if these samples are real or fake, then you get realistic images like this. A very interesting architecture, and a lot of research work going on this side as well. So I have actually planned for a group activity now. If we have time, we could look at it. Before that, I would like to end the talk by showing this slide. If you have any questions or if you want to be involved in any way, do send me a mail and I'll get back to you. Yeah.
I think, Sheetal, what we can do now is to send, because we can send the group activity as a homework to everyone and be available in the chat, because I think there are some questions in the room, and I think we would want to use the rest of the time to open up for questions. Because you are so good at explaining things, and the teachable machine, and we will share the links to the teachable machine. So this is a homework you can do to really explore what Sheetal has just been talking about. And you can also do it in group, for example, team up with a participant here in the room. But I think we want to open up for questions now, if there's any one for Sheetal. I know there were a question earlier here, Sheetal, about how do you decide which model to use, or which algorithm to use?
For how, okay. So for me, I try different sets of algorithms, and it's an iterative process. I try different algorithms and see what works better. But traditionally, if not for neural networks, there XGBoost and random forest really work for most of the data sets. So I go with them first, and then probably if it is not working, then tweak them a little bit or look at new kinds of algorithms then. Yeah. That is the process I follow, and I think most of the people follow the same process as well.
Yeah. I think that is really something to also think about, and to get into the mindset also of non-AI developers, that there aren't like one model to use. You always try to make it an iterative process, having a plan A, plan B, plan C, and then testing and trying out things. Here's a question from Mei Song. I studied process control and optimization 20 plus years ago. I felt that machine learning listed in slides was very similar to what I've learned years ago. What's your thought?
Yes, it is. Sometimes I keep thinking why machine learning has become like a new field in itself, because a lot of things have been done in the past. But I think machine learning, it's like a consortium of different fields, like statistics, computer science, engineering, and everything. So I don't think it's anything very much different to what things have been done before, except for the neural networks part in itself. Yeah.
Great. I would say that keep the questions coming. We will share the teachable machine link here in the chat, and also the link to the data set that was presented early on or earlier in your slides, Sheetal. I also want to talk about you moving to a new company very, very, very soon, because we got a question from here earlier about real world cases. Could you please give some real life use cases too? And you will start, you've been really in the field of research now and testing hardware and software for us at AI Sweden, but you will now move into a new, very fascinating area of application, AI, applied AI, which is autonomous vehicles and self-driving cars, I think. Could you elaborate on your new position?
Okay. My new position is going to be a little bit different. So I have been in the research field for 2 years now, and then I realized that a lot of research is happening in artificial intelligence and machine learning, but not all models are going into production. And a main reason for that is because the companies have not had a proper infrastructure or proper pipeline set in. And that's the reason it's always Google and Facebook who are in the top position. But that's my feeling. So now I am shifting my role a little bit and moving towards data engineering and machine learning, where I would be setting up these pipelines and see that this iterative process that data scientists do is it's speeded up in the sense. So I think I'll be more of an infrastructure person and understanding the data quality. How do we this fleet, the test fleet that we have, and the different kinds of data, that petabytes of data that we get from these autonomous vehicles, how do you manage them? How do you ensure data quality on it? And how do you kind of design a metadata store so that people can actually access it much easily? So these are the problems I'm going to be working on. A little bit different to what a data scientist does, but I'm sure it's going to be interesting and exciting.
I'm really looking forward to hearing more about that position. And you will stay in the chat for a couple of more minutes if there's any more questions. And as we said, we will share the link to the teachable machine and to the data sets later on. And Sheetal, thank you so much for sharing your knowledge and sharing your insights. With that said, I would like to hand over to Sophie now.
Thank you so much, Peter. And happy to be here. So for the remaining part of today's crash course, we have a guest, and this guest is Anna Hjalmarsson. And Anna Hjalmarsson, she's the lead AI engineer at Electrolux, focusing on spoken dialogue systems. And she uses AI and machine learning for empirical analysis and modeling of intonation. And from my research, I understand that Anna has always been interested in music and hearing, as well as speech. And she has a master's degree in cognitive science from Linköping University. She's been a researcher at Columbia and has a PhD in speech technology. I can't even say it. From KTH, the Royal Institute of Technology. So please welcome today, Anna.
Thank you very much.
Hello, how are you?
I'm good, thank you.
Good to have you here. And I know, Anna, that you have prepared a few slides for today, but I was thinking before we dive into that, do you just want to give a quick introduction of yourself and how you got interested in speech technology?
So yeah, my name is Anna Hjalmarsson, and as you mentioned, I studied a program at Linköping University called Cognitive Science, which is a multidisciplinary program targeted mainly towards psychology, data science, computer science, linguistics, etc. And actually during the final years, there was a lot of optional courses, so you could choose basically what kind of field you wanted to focus on. And then I got interested in natural language processing and speech technology mainly. So that's actually where it all started.
Great. But I think everyone who's here today is super excited to learn even more. So I'm thinking that I'll let you get into it, and then we'll leave some room at the end for more of a discussion, and then of course open up with questions for the audience.
Yeah, sure. I'm gonna share my screen. Can you see my screen?
Yes, we can.
Okay, so then I'm going to start. Yeah, I think I already introduced myself. So yeah, just feel very honored to be here as a guest. So thank you very much for inviting me. And I prepared a small presentation, as Sophie said, but you know, feel free to interrupt me. I'm happy to deviate from this presentation if you have any other interest or questions that you want to ask me about. So basically, my main area of interest and my expertise is in the area which is today mainly referred to as conversational AI. So I actually been in this field for many years, and it has been called many different things. When I started, I think it was called dialogue systems, and then there has been many different names throughout the years. But I think what you can, this technology is basically a type of AI that allows users to interact with machines using everyday natural human language, using either voice or text. So that summarizes it pretty quickly, I think. And I don't really have the opportunity here, I think, to go out through the whole history of conversational AI, which is actually pretty long. But I would just like to mention a few of the trends that I see today. So I think that one of the things, of course, that we are trying to do with conversational AI is to automate redundant tasks. So to speed up and help, basically to help, for example, call centers to reply to frequently asked questions, etc., in a natural and human way. I can also see a trend that there is more about augmenting human teams. So you actually have chatbots or voice bots collecting information from users, supporting human agents, for example. Or there's even technology that now listens into conversation between call center agents and a user, for example, and then supports the agent with tools or information that is needed for them to help the consumer as efficiently as possible. Another trend that I see, I think, is that we are now reaching a little bit beyond these like simple question answering systems, where basically we just have information provided to consumers. So we have much more integrations with multiple sources. We have integrations with CRM system. We know a lot more about the users when they contact us, for example, as if they had previous interactions, if they have open tickets, etc. So we can help the more users in a more personalized way. And I also see a trend that we are now also supporting users to complete actual tasks. So you can actually do bank account transfers, you can book your tickets, you can open service repairs, etc. So there's actually moving a little bit beyond this like simple answering systems. Then just a brief background about myself, where it all started. I think I already mentioned where it started in Linköping University, when I got interested in speech technology. And well, what happened actually when I graduated was that it was the burst of the IT bubble. So it was very difficult to get a job in IT at that point. So it was not really my natural choice, but I was offered a PhD position at the Department of Speech, Music and Hearing, which was where I did my master thesis. So I accepted because I couldn't basically get another job. But this was a very good decision, and I enjoyed doing a PhD very much. And one of the reasons actually was that I was part of a school or a graduate school called GSLT, Graduate School of Language Technology, which was one of 16 natural graduate school that was funded by the Swedish government. And actually a lot of the network that I have today is somehow related to this graduate school on NLP, basically. And then I did a short sabbatical at Columbia University, and then I defended my PhD. And then actually it wasn't natural for me again to stay in academia, but I was very lucky to get a grant from Vetenskapsrådet. So I stayed on and I did a postdoc at KTH again. But then a lot of things actually happened between the years of 2011 and 2015 in the area of conversational AI. So you probably know about Apple Siri, what was released in 2011, the personal assistant in iPhones, which of course made this technology available to a much larger audience. The speech recognition quality improved a lot, which also made it possible to build much more sophisticated systems. In 2013, Amazon released Alexa, which was very impressive because I don't think that anyone really believed that it was possible to do far-field speech recognition with this high quality. So at some point I decided here that I wanted to actually go into industry because I wanted to work with real users. I wanted to work with real data. So that's when I started a position at a small Swedish company called Artificial Solutions, which has been actually around for some time, but they provide a platform for building conversational AI called Teneo. So here I worked as a conversational AI consultant, basically building conversational AI applications for the different clients that we had at the time. And this was a very much a new world to me in many ways, I would say. I didn't know much about the industry world. I didn't know what agile development was, or I didn't know what KPI was, etc. So there were a lot of new things for me. But I had a lot of experience actually from KTH, where we did a lot of applied research. So I actually had to build a lot of systems myself in order to test my hypothesis. So that was very good. But here I was able to work, for example, with a very sophisticated smart home conversational agent, which was very fun. It didn't reach the market in the end for multiple reasons, but it was I learned a lot. So worked with a tool for identifying date and time from natural language expressions, which was very complex, I can tell you. It's very ambiguous. But after a couple of years, or 4 years as a consultant, I felt like I basically was mainly part of starting up new projects. I never got to follow anything through. So last year, I joined Electrolux as a conversational AI designer, and they have a long-reaching project improving their customer service solutions. So it felt very interesting. It's also multiple languages in Europe. Right now, we're going live in, so there was a lot of new and interesting things. And then very, very recently, I just got a new position in Electrolux as a lead AI engineer, basically focusing on the conversational AI part, but also other types of cognitive technology that can be used in the call center. So then very briefly about what I do today. So I work in a project called Consent, which stands for Consumer-Centric Transformation. So it's about getting an overall view of the consumer. So Electrolux has traditionally been a company that has used different type of external retailers to sell their appliances, but we are now moving towards getting a more direct contact with our consumers. So we want to also improve the overall efficiency in all our contacts with our consumers and to reach the full potentials of all the channels. So the part that I have been mainly worked with is a chat and voice bot called Freya. And what Freya does is that she routes calls to the right team, basically because we have a number of different teams in the call center that are specialized on different things. So Freya basically interprets what the consumer says and routes them to the right team. And she also supports the contact center agents because she collects various types of information about the appliance that the consumer is calling about, but also information about the consumer, so that once the call actually reach the agent, they can create, for example, a service appointment ticket very quickly without having to collect all of that information themselves. And then we also have something we call first contact resolution, which is basically where Freya identifies the issue herself that the consumer has with their appliance. And if she has identified an appropriate support article that we have, she will send that to the consumer and try to help the consumer basically to solve the issue that they have themselves. And haven't really talked much about the technology, but so basically what we are using is Dialogflow, which is a framework for mainly doing actually natural language understanding that is provided by Google. And we also have a lot of different integrations with our CRM systems. So we, for example, as I mentioned before, we are able to retrieve previous interaction, etc., from the consumer so that we can help them as efficiently and fast as possible. Yes, so that's very quickly and high level about me and what I do and my background. So feel free to ask me any questions that you have.
Super nice. Thank you so much, Anna. I have loads of questions, so I'm thinking we'll start with some of those and also hearing some of your generic thoughts around the field. And I want to start by just asking you as experienced within this field and for others, if they want to get started, like how do you in practice train these models, and do you want to speak a little bit more around that? And also, how do you recommend for people to get started if they are specifically interested in conversational AI?
So I think that it's such a multidisciplinary area. So I think that there are many ways into this area. And what happened during the last year is that there's actually a lot of sophisticated tools to build these agents. So I don't think that you need to be an expertise in machine learning or the details. You don't need to create these models yourself. They're basically very sufficient tools to do this. So I think that, having, of course, background in data science and things like that is of course a very good one. But also I think we need people that are good UX designers and have good experience from understanding how conversation unfolds with humans. It's something that is actually not as easy as you might, or it's something that is quite a skill. So I think that there are actually, and of course, background in linguistics, etc. It's also because many steps that you do. Of course, some parts of it is machine learning, and you have different, especially the NLU parts. But there's also a lot of development work in terms of the logic behind the conversation, and there are approaches using machine learning for doing this as well. But I think most state-of-the-art system is actually very much still developing these custom made for each system. That's actually what we do. So if you're also a developer but doesn't know much about machine learning, etc., that's also a way into this area, I would say.
So at Electrolux, do you develop the actual conversational systems in-house, or is this an external provider, similarly to how Alexa or Siri is being used? I mean, could there be one provider that just provides conversational speech systems? Or I'm thinking around Electrolux, I'm sure there are very many specifications that are specific to Electrolux and your products. Do you need to produce it yourself, the actual, or train the actual conversational model yourself?
So we do train the actual conversational model ourselves, because for conversational AI, the systems that you build are very domain specific. So there's not you can use existing data collected in other systems, etc. So you do have to train your own models. But as I said, there are a lot of tools that help you train your models, such as Dialogflow that we use. So we do, with these tools, develop ourselves, but we actually today mainly work with having external people developing the company or developing these applications, but we are moving towards having more internalized competence, actually building these systems ourselves. So today I lead a team of consultants that are building the application that we have.
Okay, yeah, that's great, and it must be good for Electrolux to have that competence in-house as well and be owning it. Anna, you mentioned Siri and some other technologies. I'm instantly thinking about Alexa. You mentioned that as well. And some of these conversational systems are claimed to be constantly listening to us as humans. How or what do you see are the risks with some of these conversational AI models, or the way in which we're using them today?
No, I definitely see risks. I guess there is no company that actually said that they are listening all the time, but I think that it's a debate, I guess. But of course, they have the opportunity to do that, and of course, they are able to collect a lot of information about you from the audio that you have in your home environment. So, of course, I don't really generally trust those companies because, of course, they benefit on the data that we provide them with. So, no, I definitely think that's scary.
Yeah. How do you think there is a way that companies working with conversational AI, not only, I mean, Apple and Amazon mentioned in this case, can ensure the privacy of the user? Is there a way to do so? And I understand if you can't answer this, I mean, it's a tough question.
It's definitely difficult, of course. As I say, we are using a tool provided by Google, but of course there are much more regulations now on how we handle data, how we store data with GDPR, etc. So I think that's very good. And then, of course, at Electrolux, we follow all of these procedures. So, yeah.
Yeah, No, I mean, it's a difficult question, but I think it's a very important topic to bring up and something that we've been discussing over the last sessions here in the crash course. We always try to relate it back to maybe not particularly privacy, but at least ethics and what the ethical implications of applying these technologies are. But going more to the positive side of things and perhaps looking a bit into the future, how do you think we are going to be using conversational AI technologies in perhaps 5 to 10 years? Is it going to be drastically different to how we're doing it today, or are there any new applications that you are particularly excited about?
So I think that although this is my main area, I think it has been a little bit difficult maybe to identify the killer application for voice and chatbots basically. But I think that what we are mainly doing today with our voice assistant is very simple task. We ask them to, about the weather or to turn on specific radio channel or about the time or something like that. So very simple command-like systems. And I also, I guess, generally have seen a trend when I was working as a consultant that there was a lot of companies that actually, we want to use conversational AI, but they don't have a clear idea how to use it or what to use it for. So I think that will be the systems that we will see in the future might be more targeted on actually providing value to both the companies and its users. So maybe we will see a little bit less of conversational systems, but I think that the ones we will see will be hopefully much more sophisticated. I think there's a lot of research going on, providing much more sophisticated methods in terms of machine learning for doing NLU, etc. And also, there's lots of progress in semantics, actually understanding much better what the consumer says. Mm-hmm. So I hope that the systems we will see will be much more sophisticated. And I also believe very strongly in this system that actually help the consumers to complete tasks rather than just, providing simple answers or informations.
Yeah, I can think of very many applications. I'm thinking about the learning space, which I'm in, where it would be great to have your sort of own AI assistant that can help you when you need, let's say, explanation to a math problem or something like that, and someone that you can ask in that way. But going on and moving on a bit to the questions from the audience, I had a conversation with Oskar Tickström, who I know that you also know, who's a former researcher at Google AI and is now at Sana Labs, and he actually held a lunch and learn on natural language processing and how that can be used. And we were speaking about models such as BERT and GPT-3, where I learned that GPT-3 is actually trained on all the data on the internet. So it doesn't matter really what language you write to it. Can you train conversational AI in the same way? And we got a question here in the audience asking if it's possible to train an AI call center in, let's say, 10 different languages, or how does this training work when you have different languages?
So we do have train a model for each language, basically. And as I said, most of the conversational AI applications are very domain specific. So I think that what we have seen traditionally, it doesn't work very well with these like very large general models, both for speech recognition and actually for natural language understanding. So
do you think it would be possible to have a model that first sort of identified what language it is this person is speaking, and then you direct them into sort of that domain model, or would that be possible in practice?
Definitely, yeah. So there are definitely methods that can actually identify what language you are talking, and then of course sending it to the right trained model, basically on that particular language. Yes.
Yeah. So perhaps we can pick up some questions from the audience here. Anna, feel free to pick up any ones that you find interesting. But I was thinking one other thing here around the technology, and we've been speaking a lot about both supervised and unsupervised learning previously in the session today. What machine learning technology would you say that you're applying in conversational AI? Is it mostly supervised or unsupervised, or do you want to elaborate a little bit more on the type of technologies that you're using?
So we are using supervised models, so it's annotated data. So basically what we are mainly working on is the inputs from the consumers, right? And you need to tag them both with the intent, which is the goal that the consumer has, and also the entities in the input, which is basically the keywords. So if we're talking about the application that I am building, we're trying to identify appliance types, or we're trying to identify addresses of the consumers that are calling, etc., things like that. But if you were working with a travel booking system, you would probably want to identify. So that's basically, I think, that where we today use machine learning for those two tasks, and of course also for the speech recognition, which is also supervised model, of course. Yeah. And I think also what we are moving against is to do multiple tasks at once. So have architectures to actually do that. So you do entity recognition and intent recognition in the same model, basically, because traditionally those have been split, doing separately.
Great, thank you. I hope that clarifies for everyone who was wondering, and particularly Carolina, who asked about that. And then I'll combine two questions into one final one here, where a lot of the conversational AI applications that we have been speaking about today are in customer support. What other use cases do you see that this will be useful? And relating this to the smart home, when do you think we will be able to speak to our fridge, or perhaps our flower, or whatever it may be? And this is obviously within the particular field of Electrolux as well.
Yes, so I'm not working in that particular department, actually, but I think that, you know, in terms of the conversational AI technology, it's definitely there, I would say. I guess it's more a matter of people actually, you know, investing in more in technology that supports Internet of Things, to actually, you know, have the connection there, and to actually have, of course, also, yeah, the capabilities of maybe you will, of course, talk to your phone rather than to talk directly to your device, but of course having microphones and the hardware to actually support that. But in terms of the software, the conversational AI, I think that that's definitely doable already. And I think it's an interesting application, especially since it's an environment where you prefer maybe to not look at your phone all the time, so you can actually interact with your speaking route into the room. And as I mentioned, of course, also with Alexa and this large improvement in speech recognition, far-field speech recognition, it actually works pretty well. So I think that, you know, the technology is definitely there. I guess it's a matter of whether consumer wants to invest in this technology or not.
Yes, I guess it's always the consumer market that's way slower than we actually think it is around adopting new technologies. But Anna, thank you so much for being here today. I hope you enjoyed it as much as we did. We're very happy to have you, and I'll hand it back over to Peter.
Thank you very much.
Thank you, Anna.
Thank you, Anna, and thank you so much, Sophie. This is really a way for us to get a glimpse into what the industry is thinking and talking about in the development of AI and the application of AI. Of course, we want to continue the dialogue and hear all of your questions. So please join the Slack channel if you haven't already. That's our way of continuing the dialogue and also hearing more from you. We will also arrange groups if you want to try out the Teachable Machine workshop, either by yourself or in groups. This was the fourth session, and the next one will be the last one. That's in 2 weeks on the 9th of June, where we will talk about society and the transformation with AI. We'll dive more into ethics. We'll dive more into the ethical debate with a certain type of workshop where we'll have an ethical debate club with fictional but near future potential applications and cases of AI being used in industry, together with Linda Leopold, the head of AI ethics at H&M Group. So that will be very interesting, and I know Women in AI will also bring an expert to that last session in a dialogue format just like this one. So with that said, I think we are spot on time today. If there's any questions, we will stay a couple of more minutes in the room. Otherwise, I'm so happy that you joined today. If there's any questions, please let us know. You can reach us either on LinkedIn or in the Slack channel. Otherwise, I hope to see you again on the 9th of June. Thank you so much, Anna. Thank you, Sheetal. Thank you, Sophie. And thank you, Jonna. See you again in 2 weeks.